welcome back to Recommend Daily Dose. I am Dr. Clinton Coleman, along with my shiny head colleague, Dr. Suraj Saggar. We have been dealing with this COVID natural immunity versus vaccine immunity response question for some time. It's actually trending. Natural immunity is trending, but the person to talk to is actually the expert. We've talked to him before, Dr. Basil Kahwash. He's an immunologist. Like, you are an expert in this field, right? And I just want to ask you a few questions. You're not paid by Pfizer or Moderna,
nope,
or the companies that make those drugs, or the CDC,
or the company that makes ivermectin.
None of the above.
So you are a scientist.
I have one employer, and it's the university.
So welcome. How's it going?
It's going great. How are you?
I'm good. I'm
good to be back.
No, yeah, thanks for coming back. We appreciate it. We try to do these COVID updates on a regular basis, but I think, like Clinton mentioned, we get a lot of questions all the time. If I've had COVID, I'm recovered, do I really need the vaccine? If I got one dose but not two doses, am I vaccinated? 2 doses versus the booster, and B cell and T cell immunity. I try to answer these questions the best I can, but I think it's worthwhile having an expert in the field come and enlighten us. So thanks again.
Yeah,
Rand Paul just put out a tweet. I think it was today, talking about maybe 30 papers talking about how natural immunity was better than immunity from vaccines. So I guess we want to clarify the role of natural immunity versus vaccine-mediated immunity.
Sure. Yeah, Basil, I'm going to tell you what I tell people, and you tell me if this is true, because the immune response to natural infections seems to be very variable, right? So very heterogeneous.
Absolutely.
You have mild disease, you may have a mild response. You have very profound disease, you may have a much more, we call immunogenic response. The vaccine, I always tell people, you know what you get, right? You're going to have a much more reliable, homogeneous response. And people usually get glazy-eyed and just say, "What'd you say?" So I need a way. We need a way of better telling people, a more maybe elegant yet simple way of communicating that fact across to our audience, to our patients.
Sure. So let's step back first and maybe talk about how an immune response forms when you're exposed to any virus, right? So all viruses are different in how they interact with our immune systems. And of course, we as individuals, whether you want to call us patients or hosts of the virus, we all have our own personal genetic factors that play a role in this. So it's complicated. I don't, pretend to try and make it sound like this is just a simple, predictable process for everybody. But essentially, to boil it down, what happens when your body encounters a virus is your immune system has machinery for processing the virus. And what that entails is basically it recognizes that this foreign product made up of proteins and lipids and other things shouldn't be in your body. Eventually, this takes some processing. It doesn't happen right away, but eventually it will, the components of your immune system will come together and they will produce antibodies to fight off the virus that will recognize something on the virus and will therefore prevent you from getting infected with the virus ostensibly in the future. So that's long-term immunity. In addition to those antibodies, there's also there's a population of cells that will exist in your body for the purpose of recognizing the virus again.
If I may interrupt, because I know people out there, they seem to remember, okay, antibodies, B cell, right? And then you're talking about cell-mediated immunity, or T cell, right? I think that's an easy way to, we're talking to patients or lay people, or Clinton for that matter, to break it down in simple terms of B and T cell immunity. So yeah, continue.
Yeah, no, that's absolutely right. Yeah. So so the B cells are the ones that they're the factory for the antibodies.
Right.
The T cells are cells that essentially are there to recognize something that is, that they've seen before, and they stay in your body. They're a population that is there to give you long-lasting immunity in addition to the antibodies. So the antibodies are measurable with a pretty simple test. The T cells, their immune protection is a lot harder to quantify. So a lot of times in the lab, what people are looking at is antibody responses and how many what we call neutralizing antibodies does the person have. And that's a surrogate for immunity. It's not perfect though. So but all of that depends upon the person recovering from the infection in the first place, right? If your body's immune system is so overwhelmed that you end up incapacitated, or you end up, or obviously if you end up passing away from the infection, you're not going to have that long-lasting immunity. So all of this comes on the back end of an illness and an infection. And you are correct to say that, the more the virus is living and reproducing inside your body, the more chances your immune system is going to have to put together a durable, long-lasting immune response.
But needless to say, and we have to get started interrupted.
No, you're not.
That's no way that we need, as physicians, healthcare providers, educators, that we want to tell people that's the way to build up your immunity, right? Have a very profound clinical course, right? Run the risk of all the sequelae of disseminated COVID. So, I mean, I think that's what we want people to understand, is that that by no means is a solution, right? And run the risk of long COVID or post-acute sequelae of COVID, as we call it now. All the anosmia or loss of taste and smell, ageusia. So absolutely. I want to go backtrack for a second, because we get this question all the time. I'm sure Clinton gets this all the time, is, hey doc, my antibodies is this number. I'm totally good. Hey doc, my numbers are this number. I'm not good. And I find it's still not very standardized, right? And I'll tell people that whatever your B cells, you're in terms of your neutralizing antibodies, I can't tell you if you are protected or not, right? There's not a standardized scale of what is protective and what is not. And, why isn't that? Why isn't it standardized across labs? And will there be a time where we can tell patients that, yes, you are protected or you're not?
I think so, but it takes a long time to develop those numbers and to really have be able to measure them across an entire population and standardize where the cutoff levels are from, at this point, I have immunity, to at this point, I don't have immunity. And this virus has been around less than 2 years in terms of circulating in a wide population.
Sure.
So the maximum that we would have been, in theory, able to measure how long an immune response is going to be persistent is 2 years. We're not even close to that right now, because we haven't been trying to make these measurements and decide that cutoff point actively during that entire time. But yeah, eventually someday, just like you've had vaccine titers, you've had hepatitis B titers checked, I'm sure, to work in the hospital, and they were able to tell you where the cutoff is for immunity against Hep B, which is a different virus. Someday, I think we will have the tools to be able to tell people that, but we're not there right now.
So measles, mumps, rubella, all the things that I look for as an ID doc when people come to me for an immune response to certain virological agents or bacterial agents or whatever they might be, it's because of the time that these entities have been around that we can reliably predict what is protective and what is not, right? So, and why is it so hard to quantify T cell immunity? What is it, in more layman terms, why is that so hard? And I can't tell, when someone says, well, I had natural immunity, doc, and I think my T cells are working. And I'll say, well, what is your T cells? They don't really know, but everyone throws out these terms in the media, in the public arena, of B and T cells. I think people will oftentimes now tell me and come to me and say, hey, measure my T cell immunity. And I'll tell them, I don't know any assay that you can.
Yeah. I don't know.
My T cells are good, man. I don't know what you're talking about.
He's got those super T cells, and we'll talk to him exactly about what he does on a daily basis to get that T cells up.
Some Arizona ice T cells, something like that. So it's a good question. It's much more difficult to measure T cell immunity. I don't know of an assay that measures T cell immunity against COVID or the SARS-CoV-2 virus in particular. Maybe there is one, maybe there are some labs that are doing it, but the tools to do it are just so much more involved than what you would need to measure antibodies. You can draw up a milliliter of blood from your blood, and I can tell you that you have this number of antibodies. An antibody is just a protein, and you're going to have millions of them in your blood, millions of different proteins in just 1 milliliter of blood. T cells are cells, and you're looking for one specific population of T cells. Cells are many times bigger. They're huge. Yeah, many times bigger than proteins. So in order to tell you whether your particular T cells give you immunity against something, one, I need to draw up a ton of blood from you in order to make that happen, probably 10 to 20 times more blood than I would for just measuring antibodies. And two, the assay itself requires trying to trigger the cells and try and measure some sort of a response that's also harder to quantify and harder to say, just like we haven't even established a cutoff level for immunoglobulin antibody measurements against COVID enough to say that this is the level of protection versus this is not. We're nowhere near that with T-cell responses at this point either. So again, it's just, really, really difficult of a task to apply to a wide population.
And I think we're probably missing the biggest point of all of this is the goal is with the vaccine is to prevent us from getting sick in the first place, not to
Correct.
have to rely on our natural immunity. If we survive with our life, our smell, all those other things, our neurologic status. But what do you say to people who said, I've had COVID, I've got natural immunity. Why do I need a vaccine now?
Yeah, that's where the question gets interesting, right? Because I think we can all recognize at this point the data is pretty solid that getting the vaccine is, if you've never been exposed to COVID, getting the vaccine is a lot safer of a way of giving your body some immunity than exposing yourself to the virus, which, as Suraj mentioned earlier, that could lead not only to a really bad outcome in the short term, could even lead to serious long-term effects like long COVID with breathing problems, with neurological issues, cardiovascular issues, and so on. So, but then the question from moving on from that becomes, okay, let's say you were unfortunate enough to have been exposed to the virus, you recovered, you got better. Shouldn't you have enough immunity from that to spare you getting the vaccine and the added immunity? That's a good question. And that's one that we need to be talking about, definitely. I haven't read the 30 studies that Rand Paul put out there in the tweet. I have read a number.
Man, what have you been doing?
Spending a lot less time on Twitter than you, apparently, Dr. Coleman.
That's true. He's a social media guru, we're just working.
I thought you were about to say queen. Anyway.
Well, you are a queen also. I want to ask two quick questions.
Sure.
One is this idea that with the Delta variant, you have high viral load in the nares, right? So is that because you're not producing IgA? And I don't want to get too technical, but this is even for the docs or healthcare providers out there. You're producing IgG. So is this why you still have a high viral load in the nares? You get more of a respiratory illness if you have a breakthrough infection. You don't get the severe pneumonia because you have the IgG that binds to the spike protein that prevents attachment to the ACE2 receptor. But so that's one. And then two, my understanding is that the T cell, it takes time, right? So do you fear that, should we be telling patients that, hey, if you've had natural immunity, and they may say, well, yeah, my antibody titers might drop, but I still have this T cell immunity. And what I usually will tell people that this takes it's a little further along to get that moving. And in the meantime, your body may become overwhelmed by COVID-19 before your immune system and your T cell mediated immunity really takes off.
Yeah. So to your first point about the Delta variant and the virus reproduction inside of, or the amount of virus that is measured inside the nose. Yeah, there have been a lot of issues raised as far as, is that really a reliable measurement of somebody being infected with the virus? Because sometimes you're right, it can get inside of the nose and reproduce just on the surface of the nose, but not really infect a person. So it's tough to say that is evidence of infection necessarily, especially if the person's asymptomatic.
Correct. Right.
And yeah, you're right that the Delta variant being much more infectious is much more likely to get in and attach itself to something. But whether or not that's going to cause disease is the real question. In order for as you know, an infection is an invasion of the body. And if it's just sitting on the surface, it's not invaded you. Versus if it's deep down, that's when you can have these serious symptoms and long-term consequences potentially.
And that's kind of the idea of telling patients that, yes, the vaccine is designed to prevent disease, not necessarily infection. You can still test positive, have a runny nose, water your eyes.
Absolutely.
Test positive on PCR, but you're not going to have disease. And I think a lot of people still have difficulty ascertaining that, I got vaccine, I still got COVID, doc,
Sure.
And I'll tell people, look, well, what symptoms do you have? I got none, or I got a headache, or I was going to go to Bermuda and I got to get tested, I tested positive. So I think it's really important just to reiterate the idea of infection versus disease for sure.
Yeah, absolutely. And I want to address your second question also, which is also a very good one.
Sure.
It kind of goes back to what we were talking about earlier with, after you recover from an infection, you do develop immunity. Yes, that's absolutely true. So people who have recovered from COVID, I'm not denying that they will have immunity in the aftermath of recovering from the infection, but we don't know enough about that immunity, how robust it is, and how long lasting it is, to your point also about how long it takes for it to fade away. There is evidence, quite a bit of evidence in papers that I have reviewed that were not among those 30 papers probably, that seem to show that immunity tends to wane over time. Just like it may wane over time post-vaccine, it certainly seems to wane over time post infection with COVID.
Yeah, sure.
Yeah. So there was the very highly discussed study that came out, I believe, in August or September from Tel Aviv, where they showed that the headlines that ran said natural immunity, which for reasons I'm not going to get into right now, not really a term that I use, but they said the natural immunity provides 13 times more protection than immunity that's induced by the vaccine. And they were looking at a pretty short window of infection in January and February among patients who were vaccinated and those that had previously been infected with the virus. A couple things with that paper. One, when they broadened out the timeline to 6 to 8 months rather than just 2 months, that 13 ratio dropped down to 6, so it cut it in half.
It was much more modest.
Imagine that. Yeah, you can imagine if you extend that out over an even further period.
It would drop even further, right?
It's going to drop even further, right?
Yeah.
And then the other thing that got buried in that paper that wasn't widely discussed is the people that got one dose of the vaccine, meaning the people that had post-infection immunity and still went and got one dose of the vaccine, their odds of getting reinfected were about half of those that trusted their natural immunity or post-infectious immunity, I should say, by itself to protect them from COVID. So there's still clearly a role for augmenting your long-term immunity with vaccination, even if you've had the virus in the past.
Yeah, I think we're dealing with the false equivalence, assuming that, the argument shouldn't be natural immunity versus a vaccine. It should be preventing the disease completely. You see now people who are sick and hospitalized are overwhelming majority of those who are not vaccinated. So I don't even think a natural immunity has a role as far as preventing disease. We've already failed that point, right? You already got the disease. So I think quantifying whether natural immunity versus vaccine-related immunity, which one is better, I think is probably irrelevant, because the whole point is to not get sick anyway. So I think it's really important to weigh all those risks. And I think the new thing is with the kids, right? They're saying, kids are young, they can bounce back, just let them get sick. I don't know what parents saying that, but let them get sick and see how they do. So
yeah. And that's reasonable with something like a common cold, rhinovirus, something that we're all going to get 15 times in our lives anyway.
Or even chickenpox,
Right. Yeah. But there's different ways of looking at things because the diseases are unique too.
I'd be remiss if I didn't take this opportunity to ask this question, having an immunologist here. And I was just a little shameless plug, but our site was actually the first in the world to enroll a patient in the Regeneron's monoclonal antibody. And we're
wow.
So we are starting a new trial, and we are actually the first site to get activated. And I am the PI, so full disclosure, right? But this is just a scientific question. Looking at, because Clinton mentioned, well, hey, you're vaccinated, better than a natural infection. But we know that some people never mount a proper response, right? Either they're on different biologics, on chemotherapeutics, they're on high dose steroids, they're on monoclonal antibodies for various reasons, what have you. So we're actually starting a new trial in people who are at high risk of getting long-term multiple sub-Q injections of the monoclonal antibody moving forward. And this is basically prevent those at high risk, even if you're vaccinated, from developing COVID going forward. So I was just wondering if you could just, from a very basic perspective, what would prevent someone from mounting an adequate response? I mean, what is it about? We're looking at rheumatology patients, oncology patients, obviously, and MS patients that are on biologics. Yeah. What is it, and how can we predict, and which patients in particular? Because we're actually trying to advertise the study. This is an outpatient study, mainly of people who may be vaccinated but may have a ill response, right, to the vaccine. Consider getting these monoclonal antibodies as a pre-exposure prophylaxis. It already exists as a post-exposure prophylaxis. So just a couple of thoughts about what would prevent, or which patients in particular you're concerned about that would benefit.
Yeah, I love that question. It's a little technical, but I'm more than happy to get into it. So I'll start by saying that everything that I've said so far about the normal human immune response, I'm talking about people with healthy immune systems. So, which is 97 to 98% of us, but there are people with significant immune, who are immune compromised.
Deficiencies, right? Either acquired or primary or acquired. Yeah, sure.
That's what I was trying to say. Yeah, either they have some inborn problem or some intrinsic disease that's causing them to have a weakened immune system, or they're on some sort of an immunosuppressive treatment that suppresses some part of their immune system. So for instance, I just want to give one example of that, which is you mentioned oncology patients. Oncology patients are often treated, especially patients with lymphoma, are treated with something called R-CHOP, which the R, it's a combination of medications. The R is rituximab, which is a drug that exists for the purpose of wiping out your B cells. That's the point of the drug, because in those patients, their B cells are the root of their cancer, or what can be, in a lot of cases. So they put them on this treatment, but of course, if you're wiping out your B cells, you're not going to produce your own antibodies. Sure. And it's sometimes that's true while you're on the treatment, but in some patients, they just never really recover their B cells. Their B cells are always just kind of low, and they're never able to really mount an immune response for the rest of their life, unfortunately. So those patients have weak immune systems. And in that patient population, if your goal with giving them immunity is to provoke an immune response that at least as part of the immune response increases their antibody levels, then that's not an option for them. You're not going to achieve that because they don't have functional B cells in the way that the normal person does. So what you're talking about, and which I think is a really cool trial, and I'm really interested to see where it goes, is having those patients use passive immunity, so antibodies that are collected from donors, blood donors in the general population, right? And that way they will have circulating antibodies against the virus in their body as almost like this is something that I would call an artificial immune shield, as opposed to natural immunity, which I would say both the vaccine and recovering from the virus are forms of natural immunity because they involve using your body's own immune system. This is more like an artificial immunity because
just to be clear, this is not a pooled plasma. This is synthetic monoclonal.
Yes, correct. Yep. But it is an interesting, proposal, because obviously these people don't have other options. Yeah. So they need to rely on some sort of a way of supplementing their immune system.
Yeah, and this is like not IV. This is sub-Q, and done as an outpatient.
Which means you can give it at home even. Yeah.
Theoretically, they're looking at sub-Q, long-acting, even intramuscular. So again, all things that preclude the need for an IV and infusion center, et cetera. So, but it has a lot of potential here. We have to wait and see where it goes.
Right. Why don't we define vaccines as natural immunity? That is natural immunity. You said it, right?
Yeah. I personally think we should. I favor using natural immunity when talking about.
It is my vaccines. when I get the vaccine, it is my God-given immune response that's ramped up, and that's.
But the antigen, well, I mean, I guess my thought is though,
antigen is foreign no matter what.
But you're producing the own antigen, right? They're giving you messenger RNA to produce the S1 subunit of the spike protein, and then you're making antibodies against it. But that's still, well, I don't know. We have the expert here.
Well, you're right, but I would say that the
antigen, whether you made it or whether you help facilitate that production or not, right?
Right. Yeah, I would say that the immunity itself is. You're right. The way that you're introducing it into the body is technically synthetic. Right. But the immune response is natural. It's your own body's immune processes that are that are being developed and more made to be more sophisticated in this one way.
That's an excellent point. I haven't seen any info on this. I'm sure their studies are ongoing. Is there a quantification of the immune response to someone who's had COVID and has recovered and got the vaccine? Is that better than, your garden variety natural immunity with just getting COVID, or vaccine
Is there a
boosters?
synergistic effect? Yeah.
Right.
Yeah, it's a
Yes.
good question. In theory, I think, and there is some limited evidence that seems to say that yes, you do have stronger immunity. But in general, I think the more times you're exposed to something, the more strong your immune response is going to be. So, I mean, even with the same common cold virus, like if you get it a few different times, like let's say you get sick with it 3 times, the fourth time is going to be way easier. You clear it a lot quicker, just because of the the repeated exposure is going to lead to that same immune formation every single time. And in theory, it should be milder each time too. So if your first 2 exposures were from the vaccine, then exposure number 3 should be way milder than if you had gone out after 0 doses of vaccine or after 1 dose of vaccine.
Okay.
So I think that's a good point. Go ahead.
Let me just make my point. So the real nutty thing to do, which we don't recommend, would to get COVID over and over again.
Yeah.
Just to build up your natural immunity, right? That makes
of course, yeah,
technical sense.
That doesn't make any sense at all.
So I would say, just based on that nutty question, if we're going to wrap it up, though, I think and this is something I'd be interested to see your opinion. The primary series was messenger RNA or the adenovirus, so Pfizer, Moderna, or J&J respectively. It seems about 6 to 8 months, right, with the UK and the Israeli data, that you at least clinically are increased risk of breakthrough infection. So now people say, Doc, okay, I'm gonna get a booster now, and I got my booster last week. How long is that gonna last? So is it additive? So you'll get another 6 months? Is it synergistic? And someone told me something about the amnestic effect, which so people predict this will help, it will boost you 2 or 3 years. So how do we look at that? And what do we tell patients? That, you'll need a booster every year, every 6 months? Or will this actually 1 + 1 + 1 actually is not 3? It says 1 + 1 + 1 booster is actually, 5, 6, 7.
Exactly. Yeah, it's tough to predict right now. We don't fully know. And this is, at some level, this is kind of a policy question more so than a medicine question. But there is obviously, it's going to be based on what we discover in our clinical research. But at this point, we don't fully know. But based on what we understand from previous infections and previous vaccines that have come out, there is a synergistic effect. So It should be the case that, just like with tennis, people get their tennis shots now as adults every 10 years, or at least they should. Full disclosure, I'm overdue for that. But, every 10 years you should get it. But earlier in your life, you're getting it more frequently than that. There should be this synergistic effect where after a certain point, you could at least space out the boosters, if not kind of, hopefully someday forego the boosters entirely. But that's something that we're going to wait and see how this plays out.
Yeah, because I think if we're trying to sell, I hate using that word sell, but if we're trying to educate or just, get the word out, if we can definitively say that, yes, it's synergistic, that yes, the need for repeat vaccinations will get less and less and more spaced out. I think that will help people that may be on the fence to say, okay, yes, I do it now, 1, 2, 3, and then I can wait a couple of years, and this is going to be, there's some light at the end of the tunnel. So we appreciate you. Yeah, we appreciate you shedding light on all these questions. These are all very timely questions, and this is great. Having this. We end up picking your brain more on a Friday than probably you wanted to be picked, but we appreciate it.
Oh, far from it. Actually, I was hoping to make one more quick point here.
Please do.
Sure. Because you, got me thinking now. So, last time I was with you guys, I talked about how we're going to learn a lot about our own immune systems as we learn more about the virus. I agree with you. I think that there should be this synergistic effect, and that's what I expect to see. However, I got to add the caveat that we don't fully understand the virus and what it does to our immune system in the way that we understand some other viruses. So there are other viruses that can interfere with that can escape the immune system in a lot of different ways. So herpes viruses can block some of that machinery that I talked about earlier that allows the virus to be processed, and that can actually delay recognition by the immune system. So people with herpes viruses, including things like cold sores, that's why the cold sore is there for days before your body clears it out, things like that. We don't really understand what the SARS-CoV-2 virus is doing to escape the immune system in a lot of cases. And we don't understand to what extent that's going to make it able to also escape long-term immunity. I mean, there's a lot of different elements here that are going to be actively studied, and I think we're going to learn a lot from it. But if it behaves like previous viruses, then yes, definitely there should be a synergistic effect. If there's something there that we have just never observed before that's novel, can't promise anything.
Are you saying that COVID may be the herpes of common colds going forward?
That's exactly, yeah, that's the takeaway.
Doc,
That better not be
Doc,
the title of this episode, though.
my COVID is acting up. I need a shot.
Or VZV for that matter. It keeps coming back, chronic illness.
Which is a herpes virus also.
It is a herpes virus. Exactly.
Yeah, right.
So
You need to tell him. You need to tell him. Yeah.
Yeah. Again, thank you so much for coming on today. We really appreciate it. You're still at work, I see. Are you working on any? I know you, in addition to seeing patients, you're involved with research as well. Anything you're working on in particular right now in your own lab or in your own practice?
Nothing in particular right now that I'm at liberty to talk about. We are hopefully going to be doing some pioneering clinical trials more on the allergy side of the world. But that's something that I'm going to be working on shortly. And then, as always, still involved in teaching and developing our education curriculum here. We have resident rotators with us pretty much every week. So, and fellowship, very strong fellowship program.
Thank you for the enlightenment. We appreciate it.
Yeah, my pleasure. It's good to be with you guys again.
There's a glow around Dr. Suraj, like he's been enlightened.
It's a natural glow. Even when I do the news, I'm like, man, can you help me out here? Put the light down, something. But when I used to do in the studio, they would put stuff on my head, to like just tamper it down. But
yeah, to dull the light. Yeah.
Yeah, I can try this. I don't know. I need, but this really.
We shiny.
I shine no matter what. This is
Yeah.
I'm a shining light for Clinton and his, when he's down, give him a little more energy. So I just try to shine the way for him and enlighten him, if you will.
Yes, shine from the inside.
All right, Clinton's gonna take us home. Go ahead, buddy.
Me? I don't know how to wrap up.
You can wrap it
Thanks
up.
for tuning. How do you do it? Thanks for tuning in. Follow us on Spotify, Apple Podcasts,
Yes.
Apple,
How about
anywhere
YouTube?
you can get your digital service providers. Be well. Is that how it goes?
And be well. And here, I'll pretend I'm drinking tea with my recommended daily toast.
Ah, there we go. Get me one of those. I've got a boring white mug right here. Yeah.
Where can people follow you though? And check you out.
Sure. Yeah. You all are welcome to follow me on Twitter, Basil MD0. That's BASIL MD0, or on Instagram also, BasilMe, BAZZLEME.
Hey, thanks, Basil. We appreciate it very much. That was very enlightening.